of the presentations. Last presentation by Josep Lluís Sala. His lecture is entitled Migration to Open Source Technologies in Municipal Management and Infrastructure Management using Postgres-PostGIS.
Thank you. Well, this is really a long title. We wanted to check whether there was a limit of characters. I had a shorter title, but we have a script team, and they didn't let us do it. Within and the urban infrastructures, where we are implementing different solutions within municipalities. Well, if the workshops last year, they were speaking about this and saying that growing is easy. Then the lecture this year says that starting is easy, but Postgre is very important, and we will see the development that we have done and which are improving our management capabilities. We will go to the database and we will see the different questions about pavement, different sewage systems, and urban drainage. GIS water is an open development that englobes all that incorporates all the technology, and we were also talking to Juan Luis Peñarrubia. We need data in order to manage. We cannot manage it with data, and we need with good quality data. Do we have good data in the city councils? Yes. Which format? Sometimes similar to this, sometimes it's like this, or they are well structured, and whenever we have a fail in interoperable format which can be shared with other departments, we also have this kind of information. Do we have georeferenced information? Well, yes. And sometimes it's exclusive for the department specific in the organization, the mapping department, with which has the GIS software, which is very expensive, and they have their cartography with some more layers, while the engineers and technicians with all these engineers working in the lightning, in many things, they have a CAT software, and they cannot have access to this information, which is well structured with data. Data are very important. There are, of course, some city councils which really can have a very good, can provide very good information. Betera is one of them. And then we need a good maintenance of all the different infrastructures. In order to do a good maintenance, then what you have to do is to have good information. How many trees, which species are in my municipalities? I don't know. Sometimes investments are programmed without knowing which are our priorities, which is more important. Less spend our money in good data, and this scarce capacity for the planning of the different services and infrastructures. This is basic so that we can have good results. So as we said last year, we can create our own theme layer, geo-referenced. We can provide it with data, and we can manage it. It's easy, more or less easy. We are tired to talk to people from other city councils and tell them that there is a better way to have their structure within the organization. The technicians, they open their eyes, but after they always find different barriers. We told them, well, you can start to have your data in shapefile, but with the limitations of the format itself. So for some municipalities with very few technicians, sometimes this can be good business. But for more complex structures, you need some other things. You have to go to the Postgres. If you have a Postgres and PostGIS, which has an area, an architecture client servers, you can have the data created with different roles for different users. You have the schema for the technicians who can edit that information. They can visualize another division of the information, but they cannot edit it. That should be our objective, and that can live together with privative software. In a municipality more or less big, we had contacted with a technician that is managing the sewage system. We were explaining them our specific development in the area of sewage and in open format. The man was very happy. We have a meeting. Perhaps we had there 12 people with different levels of hierarchy, and we were explaining them the advantages of open software. The technician was very happy. Until one lady that was shut up then raised her hand and said, "We have the GIS and Oracle. That's what we need, and it's enough." Okay. And then whenever there is a flood, and then you have damages, then you will have to explain to the citizens that the money that you have spent in a license, you could have spent it in your manager to have good structured data and can establish priorities for the things which are more important. That we have a unified consultation of the information. Vicente Medina, one of the developers of the GIS water, that the students they have discovered this. They have their computer, and the students connect to his computer, and he makes practices, and the students connect to that and see polygons or industrial parks which are being designed by colleagues, safety copies or backup copies. The different scheme, the different access priorities with total safety. We have a lot of development done, and then we start in shape file format. We started with shape file. We had 4 layers, and the management of these 4 layers was done by the pathologists. They had, we were structuring one layer is, for instance, the asphalt, which has a specific ways of repairing it. We have a non-asphaltic layer. We say remaining pavement that had a different series of pathologies and other repairing processes, and then the border that is the limit. Then the city of Sabadell already has it with all the data, and they are very happy about this. Each one of the pathologies, whether there are cracks, where there are different pathologies in the pavements which are classified. And then you can establish the priorities of your repair action thanks to this index. Then when there is a repair that has to be done, and these are the limit returned to 0, and the technician had to come here and recalculate the indexes again in order to have an adequate layer. Regarding database, one of the things which is very important are the triggers. I have a series of data, and whenever I modify those data, then it triggers and it calculates the formula. Also, the structure of the information changes. Whenever we have 3 or 4 layers of information, this is reduced to 2. And that could be 1 layer with geographical conditions, which could be that of the polygons, from which perhaps here either this is asphalt or this is sidewalk or whatever, and which is the repair to be done. And there is another layer, which is the one of the borders, sidewalk borders, and then everything is structured, even the curves. Another area is the utilities, sewage and drainage. We had also a topology arc node. We have the wells and the collectors, and what started to be the extension INPEPCOM. What it did was to connect geometrical layers of GIS with mathematical calculation, the EPANET from supplying networks for the calculation of urban drainage. Then that has derived into another more powerful thing that we will see now. I see that I don't see anything here, in fact. Excuse me? The structure of the architecture. Within the structure for sewage, We have here nodes, arches. Here we have a node which can be a wall, and a start, a divider, that is simplified in a layer, which is called nododat. Then we had another layer, which were the status, sediments, conservation, everything. Then we had the data of this collector and the status of this collector. And the shapefile works like this. And then we go to post-its that was created thinking in databases. So all these are two layers that contain geometry, and the rest are tables with data interrelated, where you have all the data needed by the calculation software. What is this water? And that allows communication of EPANET, EPASWIM, and ECRAS. Here we had the cooperation of the Polytechnic University through Postgres and PostGIS, and with any geographic information system. And that establishes the basis in order to mathematically modeling the networks, managing assets in an efficient way, and achieve a full operational water system, a fully operational water system. Here you have the source code. Here you have the general public license, and we use Postgres with more than 800 space utilities. Well, you can do a lot with this. More than 800 spatial functions allow us to manage spatial data in order to be able to communicate with EPANET, EPASWIM, ECRAS, and you also have the results inside the database, because it has been modeled like this. So a little bit the structure. This is the database, the software that communicates with EPANET and EPASWIM and ECRAS. Any SIG, his software can read it with field notebooks, sensors, webmap service, LibreOffice, customer relationship management, all the contents of the database is available for anything you want to do. A little bit of the environment.
Mayúsculas, no, es que estoy clicando al perdón, no. Mayúsculas de 5. ¿Sí?
Gracias. Thank you.
Un poco del entorno.
A bit from the environment, which is just water.
La gestión con EPANET.
Then we have dialogue with all the data that EPANET has. You will be able to introduce them. And as far as that was a development that established with the BF, and it was generating so many BFs, then we have to maintain that structure, because it should work with this and with a class. To finish with, we must say that the Postgres for field data capturing we could give a full lecture on this, but this is a development which is in an embryonic state, and thanks to Postgres, we could do maps for the execution of works and load data. That means with a tablet like the one, the distance meter is a cluster more. Then we can get something from Peñarrubia is programming. We asked him to program. They are open a channeling, a linear arco node architecture. So on each node we have the valve, the elbow, and a protection for another service. And here through a basic mapping that is indicating which are the lots and the different divisions. Then you can say we have this distance through the length of the facade, and then I establish a point. I note the distances, the data of the elbow, and I send it to the office so they can digitalize this in this way, which is incorporated in the Windows 7 with gvSIG. Then we can indicate the medium, the division wall, and then I have a prompt with a form that asks distance to the facade, distance perpendicular to the facade, as well as it is connected with Bluetooth. They are from the same company. They are interconnected. Then you have distance to the device. So then in situ you could place and you could place the point and do the work that usually is done in the office. And even more than that, that allows you to have to take a picture in relationship with that node, and you could have different screenshots, which type of accessory, which welding, which is the code, and this is linked to a database in such a way that you are putting all the information in situ, and this company within the database can make a traceability which is perfect for each batch of accessories, and this is more or less a small idea about what are those types of architecture. The forms were attached to different tables in the database, and which are the conclusions? Well, the important thing are data. The municipalities, they usually expend, they should spend the money in collecting data and not in private software. Within departments of the same organization, sometimes they do not want to share data, and it's incredible that somebody who is managing the streets doesn't know where is the public domain, whether this street is mine or from the neighbor. They should share the information this with the citizen. The citizen sometimes that depends on what is on the street. Why can't you tell the citizen, even if you claim you see the map and you know that that and that and that are have a priority, and we have to be bold, and we have to be courageous to say the things as they are.